thanks everyone for joining, and it gives us great pleasure to come back to our. It's a follow-up from our earlier conference that we have held, and some of the talks, unfortunately, we could not hold during that time. So there's a follow-up session. It gives me a great pleasure to introduce Professor Ravindran, who is from Computer Science and Engineering Department in IIT Madras. And he also heads the Robert Bosch Center for Data Science and AI. And for quite some time, we have been trying to get him on board, and he has fantastic work on machine learning, especially in the domain of reinforcement learning. And it's great that Ravi could join us finally. And it's a great topic, which is AI ready for the real world? So without further ado, I would request Ravi to give your talk. And you have around 40 minutes. Please feel free to take questions in between. And also towards the end of the talk, maybe we can have a discussion around some of the ideas that you will share with us.
Sure.
Thank you.
So thank you for the introduction. And so I've tried to keep the talk fairly lightweight, and throw up some of the ideas that then I would really love to see us talk more about these. And so the topic is AI ready for the real world, and some of you might actually think, hey, AI is already everywhere, right? I mean, what do you mean is AI ready for the real world, right? So my title is Duh, right? So, and in fact, AI is doing all kinds of amazing things, right? Not just these social media stuff, but AI is actually making a difference in the real world, right? So AI is used in making bail decisions. AI is transforming the financial industry, making lending and loan management decisions, right? In fact, AI in science. I had to update the slide yesterday, and then there is another new article today on how AI is helping solve some other important question, right? So looking at chemistry, looking at nuclear fusion, right? And what you're asking these questions about. Here is the thing: like AI can even flip burgers. Okay? So why are we even talking about this AI ready for the real world? It seems to be already there, right? So let me talk about the prevalent thinking, right? The prevalent thinking in building AI models is that all you need to succeed is large volumes of data, right? Large volumes of examples from which your system is going to learn, and these examples are preferably tagged examples. I mean, somebody tells you what the actual output is, and then you can learn from this, right? And for some problems, you only need a simulation model. You don't even need this kind of tagged examples. You just need a way of generating interactions with the domain, right? So for example, the most popular of these are like these game playing systems, right? And they created a lot of buzz, right? So AlphaGo was one of the earliest success stories from DeepMind that kind of reignited interest in reinforcement learning, which is my primary area, right? And so this is always going to be like a landmark event for us when AlphaGo beat Lee Sedol, who is arguably the strongest Go player in history. And in fact, it did not just beat him; it beat him 4-1, right? It's pretty strong, and it basically learned by through simulations, playing against copies of itself and looking at some past games, but it was never actually given any examples. In fact, because it learned by itself, right, it could do things like this, right? So there was this very famous move 37 in the second game of the match, right? And that flummoxed even the world's best Go players. I'm reading from this extract, right? That's a very strange move, said one commentator, himself a 9-dan Go player. And I thought it was a mistake, said another, right? And then Lee Sedol took nearly 15 minutes to formulate a response to that, right? And so it's like something that people had not seen before. And it turned out that this move 37 was very crucial in establishing a significant advantage for the AI agent, right? And it's basically doing things that humans hadn't realized before that could be done. All of this sounds really fantastic, right? And so a lot of investment is going into building more data sources or more better detailed simulators, how to go from sim to real, or how do I crawl the web, right, and use the data from the web in building models, right? Data is what we call new oil, new water, and driving the new electricity, etc. Right? But one of the things that we really have to keep in mind is, right, so this is not really how we learn, right? We have teachers, right? We don't learn only from examples. The teachers actually tell us a lot more, and they give us a lot more structure, right? So learning this just from these examples, right, causes some problems. So all of this is fine when the going is good. So here is an example where an AI is basically learning to describe a picture, right? A person riding a motorcycle on a dirt road, or two dogs playing in the grass. Yeah. Group of young people playing a game of frisbee, I think is amazing because it managed to get the small frisbee in the image also. But then you get all kinds of craziness like that, right? A skateboarder does a trick on a ramp. There is neither a ramp there nor a skateboard, but somehow it catches a skateboarder. And likewise, a little girl in a pink hat blowing bubbles, right? So that goes on. Now I really want to know why the AI did that, right? So when the going is good, it's all fine. We are really rarely asking for explanations, but when the going goes bad, right, then we start asking questions. Right? So why did he do that, right? And now this is fine, but then the going can really be wrong, right? So for facial recognition, we've heard stories of all of this, right? Leads the police to arrest the wrong man, right? And likewise, the bail decisions going really wrong because the software was significantly biased, right? And likewise, GPT-3 reflects societal biases in gender, race, and religion. Right? And here is another famous example where you give it a picture of Obama, and it recreates a white man as being the actual subject of this image, right? So it starts raising serious ethical questions, and then you have to ask these, start going and asking these questions, right? Why did this happen? So the fundamental problem with a lot of this AI is that it's learning associations from data, right? And but it has no knowledge of the structure of the world, and the data, in effect, is an imperfect representation of the world, right? And there's only so much that you could expect to gather from the data, and it has no clue about the structure of the world, nor of the processes of the world. For example, a doctor could potentially tell you why some artifact she saw in an image is the reason for a particular diagnosis, right? Not merely because 30% of the people who had this turned out to have cancer. Therefore, you have cancer. That's a very unsatisfactory response, right? But then the AI at best can give explanations like that, right? And there are a whole bunch of other things, right? So the AI wouldn't be able to understand what causes biases in a data set, because it has no idea of what are the societal inequities that are there from the process that actually generated the data. Right? So all of these are really fundamental issues, and some sense, AI has been drunk on the success stories for the last decade or so, and slowly people are sobering up and actually starting to look at some of these hard questions. Right? So I'm going to talk about a few of these. So the prevalent thinking, like I said earlier, right? So we have data, you feed it into an algorithm, and then it spits out a model, and then you go ahead and you're ready to use the model in the real world. But that's not the case. So here are some examples of what happened, right? So here is data, right? And the data turns out, so here is, sorry, not the data. Here's some example of what happened, right? I don't know how many of you actually have come across this, but sometime back there was a huge hue and cry in the Indian press. So if you search for the ugliest language in India, it came up with Kannada, right? Okay, so
people need to be told who speaks Kannada. Kannada is spoken in Bangalore and the state
40 million people, at least 40 million people speak Kannada. Okay? So it's not right. So Google actually had to apologize for Kannada and for this, and this is the apology, quote unquote apology they came up with, right? It's like kind of stretching the word. Sometimes the way content is described on the internet can yield surprising results to specific queries. We know this is not ideal, but we take corrective actions when we are made aware of the issue. So they're basically saying that, hey, there is no way we can actually proactively prevent all of these things happening. And the only way we can do it is, post facto fix the problem. Right? So that's not great. And here is another famous example that came from this, the bail decision-making problem, right? So there was this two people. So Vernon Prater, who is white, a male, and he was classified as a low risk to be a repeat offender. And Brisha Borden, the black female, was classified as high risk, right? On a scale of 1 to 10, Vernon got a score of 3 and Brisha got a score of 8. right? But then if you look at their records, right? So Vernon had 2 armed robberies and 1 attempted armed robbery prior, and then based on whatever bail decisions were made, right? So he was released, and then he was subsequently arrested for a grand theft auto, and this happened after the AI labeled him as low risk. While on the other hand, Brisha had basically had 4 juvenile misdemeanors, and after she was released, there was no further offenses from her. Right? So basically, what was happening is that black people were generally being thought of as being a high risk, right? So here is the thing. So the AI labeled as high risk, but they did not re-offend, right? So it made one kind of error. Nearly 50% of African Americans on which it made a high risk decision did not re-offend. Well, only 25% of the whites did not re-offend, right? And similarly labeled as low risk, but yet went on to commit further offenses. That was for 30% of the African Americans and nearly 50% of the whites. So you can see that there's a real bias here, and it was literally affecting people's lives. So, and after this study was done, the US court stopped using this tool for making bail decisions, right? And likewise, Amazon had this recruiting tool that was shown on analysis to have a significant bias against women, and then they had to go on. So there are all these things, right? So you take the data, you train a model, and then you end up having all these biases, right? And so one area that we should be looking at, right, in terms of improving AI to make it more reliable for the real world, right? So we start talking about fairness, right, and also the notion of how the social impact of AI would play out, right? And so we really need to formalize notions of fairness, ethics in systems that we intend to deploy and in the domains that we intend to deploy them. And of particular interest to me and our center is the fact that notions of fairness and equitable distribution and things like that actually both legally and from accepted social norms differ very much from culture to culture, right? And there has not been much work done in the Indian context on what constitutes a fair decision making, right? And I would say that there's not even been done outside the scope of AI, but that's a larger discussion. But this is something that we are very interested and keen on pursuing, right? And the other question, of course, is that can you explain the decisions of the model? And apart from being mandated by some of the EU regulations recently, right, especially in the fintech domain, it's very important that we are able to explain decisions that we make, right? So it's not enough to say your loan was declined. You need to say why and how you can redress it, right? So all of this is important, and AI systems, like I told you earlier, right, are not really in a great situation for that. And here's a quote from Feynman: "If you can't explain something to your first-year student, then you haven't really understood it." So here is a quote, right? The self-driving Uber car kills pedestrian in Arizona, right? They had no way of explaining what really went wrong there. And then you look at this, right? So you start talking about billions of parameters in models. Right now, it becomes more and more challenging. What is a billion parameter based decision, right? How do I explain that to people, right? So explainable AI, especially because more and more of the state of the art solutions are coming from these billions of parameter neural networks, is becoming harder, right? And then there are other concomitant issues for that, right? So you also have this notion of debugging the AI system, right? So how robust is my network, right? How robust is my deep neural network? And often you need explanations for you to do the debugging, right? So you need to understand why it went wrong in some way so that you can actually fix it. So even if it is not explaining to an end user, you need it as a debugging tool. So that's another area that we should be looking at. So, and I'm interested in looking at the more human in the loop approach to this kind of explainability, right? So because especially even I'm not a huge believer in building end-to-end standalone reinforcement learning agents. I believe that AI agents would be coexisting and co-working in the workspace with humans, and at that point you need to be able to explain decisions first of all to post facto explain why you did something. But if you're going to be in a team, you need to a priori explain the decision so that the human gets buy-in into whatever you're trying to do, right? So explanations nowadays, mostly act like this, right? So here's the original image, and you say this dog, and then you light up a few pixels there in the image and say, oh, I said it's a dog because of those pixels. And then you say it's a cat, and then you light up a few more pixels here and say, oh, I'm saying there's a cat in this image because of these pixels. Okay. But now, from a human who's looking at it, this looks like a reasonable explanation because it lit up the face of the cat. But here, it just lit up the two hind legs of the cat, right? Now, when you're trying to find out if there is a cat in the image, especially when the full cat is visible, you're not going to hang your hat on the two legs that are there, right? So for a human to understand what these explanations are, it's challenging. Right? So
Ravi, there is a question from Sham. Would you like to take that?
Sure, I don't mind taking it. I'm sorry, I've turned off all the notifications so that my slides are completely visible on my site, so I was not able to see the question.
Okay, all right. So I guess Sham can have.
Yeah, please ask the question.
Sham can just talk. Yeah.
Okay. Yes, I think early on you made a distinction between AI extracting information from data versus humans having information about the structure and the processes. Now, is it not the case that ultimately humans also extract information about whatever they know about the structure, processes from data, and it's just a matter of different level of analysis and different level of data?
That's a great question, right? So that's a fantastic question. And the point about many of the things that we understand about the structure of the world is that the analysis was not really replicated from the data by every human who is using those structures, right? You had Newton, who understood gravity, right? Who talked about laws of motion, and everybody uses it. But it's not that everybody who sees objects in motion, the data that they have, everybody is not able to derive the structure from that, right? The fact that you are able to communicate and transfer the knowledge of the structure from one human to another is what makes us so efficient in generalizing and solving your problems. And the AI still haven't cracked the problem. I don't have a way that I can communicate the structure to the AI or a deep neural network in an efficient way. So I completely agree with you. So
sorry, Ravi, can you just repeat that? We don't have a way of transferring what?
We don't have a way of transferring the structure that I already know, right? That some other process has analyzed it and derived the structure. I don't have a way of transferring, or I don't have a way of giving it a priori to the AI and say, okay, look, here is the structure. You go ahead and build on top of this, right? So the reason
you can't transfer what is already learned from one AI to another. They have to learn it from scratch.
In very limited settings you can, right? In very limited settings you can, but not in general.
What would be an example of
something that I can transfer?
An ability to transfer a structural or process knowledge in AI settings?
Okay, so one example that people use a lot, right? So is that these deep neural networks, right? Have this kind of a process where the initial layers are trying to extract some kind of features, right? It could be like small textures or repeating patterns or edges and changes in color gradients and things like that, right? So it recognizes these kinds of patterns from the images, and then the later layers kind of put them together to form objects, and then finally it recognizes objects in the images, right? So
that's a limitation of deep learning models of AI, but not of AI in general.
I agree with you on that, right? But then I had to go back and ask, what are the most successful, large-scale deployments of AI that are out there, right? And most of these turn out to be deep learning systems nowadays, right?
Let's continue.
Yeah. So I'm far from it to argue that AI is deep learning, right? So in fact, I'm going to say that you shouldn't be blindly following AI. So you asked me for an example of how transfer works. I'm just telling you whatever is the most popular example that people are quoting now, which happens to be deep learning. Right? And even if you want to say that, okay, I want to use AI systems to do inference, right? So non-deep learning systems where I'm going to transfer knowledge and things like that. Again, I would say that it is limited in the sense of what is the language you adopt to describe the models in, right? So, and it's true. I mean, even humans are not perfect in that sense, right? So it depends. You need to know the language of physics before you can adopt models from physics and transfer it. So that limitation is still there. But like you said, right? So success also has a currency, right? And of course, these kind of explanations become more critical in healthcare. I don't know. Since we have enough discussions going, I had a small fake dialogue here. So I'll go run through it very quickly, right? So suppose I say that the AI says that looks at an image and says, "Hey, this eye seems to have diabetic retinopathy," and then somebody asks why, right? And the AI comes back and say, "Hey, this looks like regions that I saw only in people with diabetic retinopathy," and the doctor says, "No, I this is not diabetic retinopathy, just normal age-related macular degeneration." And they say, "Well, I never saw that earlier, right? You did not show that to me during training. So it's your fault, not my fault. So based on my training data, I'm going to tell you that this is something that it's diabetic retinopathy, right?" So of course, the AI is not going to say any of these things. But then the question that we really have to ask is, was it our fault? It is obviously our fault in building, making the data set enough representative. And of course, I can talk about robustness. So that's a school bus. I add some noise, and that's an ostrich, right? And yeah, so it might be the peculiarity of deep learning, but still, it's something that you really need to understand as to how do these adversarial inputs, right, affect the performance of these deep learning systems. Right? And likewise here, so you have panda plus noise becomes a gibbon, and so on and so forth. So the AI is not, most of these deep learning based systems that are being trained are not really robust, right? And here's an example from a football domain, right? So here is an agent that is learning to kick the ball into the goal, mostly does fine, right? But then when the goalie does something completely unexpected, as lying on the ground and flailing his legs, right? And the player also gets completely confused, and then it just basically wanders off like a drunkard from the playing field. Right? That's because the goalie doing that unexpected thing is not something it has seen during training. Right? So it's not just a question of getting a small limited model. It's also a question of, even though there is a simulator that is capable of doing all kinds of capable of simulating all kinds of behaviors, you typically don't explore the entire input space, and therefore you do build fragile models. And that particular fragility that is there in the RL case would have been there even if I had been using a lookup table for representing the system. Right? And of course, there's all this question about data confidentiality, right? So I give data to build a model, and then somebody can actually de-anonymize the thing, right? So for example, this is a famous story back when Netflix released their data for their Netflix challenge, right? Researchers were able to reverse Netflix anonymization. There was all the stories about other kinds of anonymized data being de-anonymized by activists and being released on the public domain, like the health records of the Massachusetts governor and so on and so forth. And so when I start giving data to the AI systems, right, for building whatever they want, they have this notion of not just privacy but also trust in both how the data is being handled, right, and also in how much I can trust the decision. So there is all this issues with regard to privacy and security that starts affecting how reliable or how much ready the AI is for the real world, right? So here are a few things that I kind of put together from one of the documents that the Indian government produced on notions of building responsible AI, and is largely derived from the principles of responsible AI put out by the World Economic Forum, right? So you'd say that the AI is responsible if you can understand the functioning of the AI. That leads to more robust development. And the second thing is, if you're able to explain the functioning to end users, that basically engenders greater trust in the operation. And it should have consistency across stakeholders, which leads to fairness. And then you should make sure you pay attention to inclusion, make sure you don't deny service to anyone, and not just in the sense of fairness, but also in the sense of accessibility and exclusion from that, right? Then there are other issues like accountability and liability, right? Who is at fault? There are so many stakeholders involved in building an AI system, and without clear chains of clear chain of responsibility and fixing liability, building large-scale commercial system is going to be fraught with problems. Right? And of course, already talked about the privacy risk and security risk, and also societal concerns in terms of using fake images and other things for maligning people, and also looking at the impact on jobs of use of AI, right? And so, how much time do I have? About 10 minutes?
You have around 12 to 13 minutes.
12 minutes. Okay, great. Fine. And I can go on. So there are a bunch of other things we have to talk about, right? This is the transfer learning setting. It's not like, forget about transfer in the classical sense, right? But the world is not fixed, right? So there is going to be drift in the data, drift in the processes that generate the data. And just because I have put an AI into the system is going to cause changes in the way the data is generated, right? So we have to worry about those issues as well. So the data has to be transferable because we want to get domain information to build on and not having to reinvent everything. But more than that, data is constantly changing, and we have to worry about. I say that there is a whole bunch of software engineering issues for AI, right? That we have really not started thinking about when we start thinking about AI in the real world, right? So things like, what is the actual life cycle for AI systems, right? How do we maintain AI systems? Is that a way? So every AI system needs to have some kind of performance monitoring happen, right? And you have to make sure that there are ways in which you can continuously be adapting it, and so on and so forth, right? So a lot of these issues need more careful thought when you're trying to build these systems, right? And then we have this whole thing about the delivery of the AI system, right? So building everything on the cloud is great, and just like you saw now, I was not able to connect from my primary network, and I have to use some kind of a secondary network. So it's fine for me because I have this choice. But quite often we need to basically make sure that your AI is compact enough to run on the edge. So these are all engineering considerations that need to be taken into account, right? When we are building AI systems of real world. Right? So the way forward for AI is undoubtedly successful in very, very specific domains. Like so, I always say that now the current big wave for success in AI have been in domains largely where the cost of failure is not very high, right? So, for example, in voice recognition system, if my Alexa doesn't understand me, I just say repeat something a couple of times, right? That's not a big deal, right? So in such cases, AI can be left out into the world unattended, and they'll still perform okay, right? But then there are cases where the cost of failure could be very high, especially in like finance domains or legal settings and healthcare, right? Where we still need to have some kind of human oversight on AI systems. We're not at a point where we can be ready to use the AI unattended, right? And I'll always say the current AI-based systems understanding of the world is about that of a 2-year-old. I'm talking about largely the current popular system, right? This is mostly the deep learning kind of system, right? And we have a long way to human performance, right? Human-like performance. But then again, you have to ask this question, right? So when I say human-like performance, what human are we talking about here, right? So there is this moral machine experiment run at the MIT Media Lab. I'm pretty sure most of you know what I'm talking about here, right? So there is a car with some passengers in it, and then there are people crossing the road, and then you could either hit a barricade and cause some kind of injury to the people in the car, or you can swerve and hit the pedestrians and cause some kind of injury to them, right? So what would you do? Would you hit the barricade, or would you hit the pedestrians, right? And it turned out that there are significant cultural variations. So look at some of the samples I have there, right? So people from Japan, Norway, and Singapore were more keen on sparing pedestrians, and the least emphasis on sparing pedestrians came from countries like China, Estonia, and Taiwan. And likewise, this is actual results of this survey, okay? And there was most emphasis on sparing young people, right? In France, Greece, Canada, and UK, and less emphasis on sparing the young. Taiwan, China, South Korea. It's just the numbers, right? So now I want to build a self-driving car and that's going to make these kinds of decisions. So which one should it match to, right? It will depend on potentially on what space they are operating in, right? And so this is just a very simplistic example, but just raises the point. Even when they say human-like performance, it's not clear what it's talking about, right? But this is my fun slide to close off. But in the meanwhile, while we are working on all of this, we still have to handle all these AI systems with care, because it's like a 2-year-old, but it's more like this kid than any other 2-year-old, right? So that's basically it. So my summing up for this is we are closer than ever to functional AI, but I believe we thought this back in the 50s, right? With the perceptrons. So again, we still don't know how close we really are to functional AI. But importantly, they started affecting many aspects of everyday life, right? So we know that it's for sure that it's affecting many aspects because lawyers and lawmakers are talking about it, right? In fact, I don't know about the UK, but our prime minister works in AI in at least a couple of talks every year. Right?
Actually, this leads very nicely to a question by Shyam. Shyam, do you want to ask this about the legalities?
Do you want me to ask?
I can just give me 1 second. This is my last slide. I'll be done with this.
Okay. All right.
After that, we can go to the question.
All right. Sure.
So for me, the biggest danger from AI is humans rushing to market before the technology is ready. AI itself is not ready. I mean, all of us know that. Right? And so we really need discussions on regulation for AI. Really. Okay. Was it really your fault? Whose fault was it? And before we get AI to the real world. So my answer is AI ready for the real world? Maybe not yet. Right. So that's our center. My plug for it. So please check it out. Now I'm ready to take questions. Yeah. So
yeah, Shyam, please go ahead and then Sherry.
Okay. Thank you, Professor Ravindran. Just to follow up on this, I think lawyers have had to deal with this for a long time. I'm not a lawyer myself, so please don't worry. When automobiles and locomotives were introduced almost a century and a half ago, people raised questions when there were accidents. Somebody was killed. Was it the car or the driver? Who was responsible for it? Was it the machine or the man behind it? And I think that the argument that you mentioned about accountability of AI appears to be similar to me. And even today, we can see shades of that argument in the debates, the gun debate in the United States. The gun lobby argues, as you can see in the advertisements, guns don't kill people, people kill people. And I'm not arguing that that's a correct argument, but it is an argument.
Sure.
So the accountability issue is not that new, and I'm sure it goes back, way back, before automobiles and locomotives. And what is different about AI?
Okay. So the problem with AI is that so we don't really still have a complete understanding of what's happening in AI today, right? There are people who generate labels, and then people who build models with that, and then people who actually deploy it, right? I mean, who build systems around the models that were built on this, right? And then finally the people who use it. So now with automobiles, right? At least I have an understanding. I know that there are some experts somewhere who knows exactly what the automobile is doing, why it is doing that. Then I can. Sorry, can people still hear me? I'm getting a message that my internet connection is.
Yeah, we can hear you now.
Okay, great, thanks. So, at least there, I mean, there is at least somebody who can sign off saying that, yeah, I'm completely satisfied with that my system is passing all safety checks, right? But when you're talking about the modern generation AI systems that are being put out, I don't know if anybody is willing to even sign off. Even if somebody signs off saying that their AI is 100% reliable and it's basically the person who used it is at fault, and I'm not going to buy that, right? Because we are working with cutting edge stuff and we know how unreliable it is at all kinds of scenarios. That's one part of it, right? So we have different regulations.
Reliability does not exist, in any domain.
That's fine. But even if I go wrong, right, I have no idea why the AI went wrong. Right? So it's just that the technology is not at a point robust enough for me to say that, hey, I'm happy releasing it to the world and it's the end user's responsibility. You can always say that if you put in there a disclaimer saying that, hey, I'm not sure how this thing will behave when you actually start, training it with real data. So this is something that happened a while back, right? So Google had this product that they built for diabetic retinopathy. It worked fantastic, right? They were doing great. And then they tried to come back and use it in the Indian hospitals from where they had gathered some of the data. And it turns out that they had basically curated the data and picked the best of the images, and then they had actually built a model on top of it. When they tried to put it out into the real world, there's so much variability in the data that the model was not doing that great, right? So now, if Google had established that in very nice controlled laboratory conditions, or even in a Western hospital where there is a lot more quality control in how these images are being made, then they can come back and tell people, hey, I've done this testing, you now go use it in the real world. And somebody uses it in the real world and then they find that it's not working. So is it to put the blame again? Or
what I'm trying to get at is it a quantitative issue that AI is in an early stage of development and we could wait until its reliability levels get to whatever the error rate is reduced to some specified value of epsilon or less? Is it a quantitative issue or is it a qualitative issue of principle that AI is somehow different from other technologies that we have lived with for thousands of years?
Okay. That is a strong quantitative argument to make, to say that we're still not ready to put it out there. But then there is also a qualitative agreement partly, right? So when we start by saying that AI is a technology, right, it's not correct, right? AI is actually a collection of technologies in some sense, right? So the kind of the checks and balances that you should have for AI that works with vision versus AI that works with language, because the technologies are very different in some sense, right? It's not like you have come to a point where you use the same architecture, the same training regimes for working with one versus the other, right? In fact, they're a collection of technologies. And I believe that for each vertical that you're using, quote unquote, the umbrella AI technology term, you would need to actually evolve regulations separately. And I think once we have that kind of a clarity as to, that we are actually talking about different things, we're talking in different domains. So for example, fintech needs a completely different set of regulations versus what you would do in healthcare for AI adoption, right? Then we are fine and ready to talk more about that. So that would be the other differentiator for me. That's not to treat AI as a monolithic technology and try to regulate it.
Excellent. Thanks, Ravi. Sherry, you want to ask your question quickly?
Yeah, I mean, I can see Vincent getting ready for his talk, but I mean, Ravi, the issue about structure and learning, right? Yeah. So you know that video you had about the footballer and the goalie, right? You said, okay, the football when the goalie just laid flat on his back, not defending the goal, the footballer got confused, right?
Yeah.
Because you said, oh, that was not in my training. But then humans have similar problems. I mean, the entire great financial crisis was because a particular instrument, these were commercial paper. In the old days, we knew commercial paper. You wouldn't know what that is quite. But it is one of those things that always cause what are called credit chains and vulnerable credit chains. But then we got a new avatar of commercial paper in the form of securitized assets, it's called asset-backed commercial paper. Suddenly that threw people off. We couldn't understand because, that would cause problems. So we didn't then respond to that. So how is it any different? I mean, you're saying, okay, the AI wasn't trained, but humans make such big errors as well because we are blindsided. We are fighting yesterday's war. We also are hidebound, isn't it?
Yes, we are. But the problem here is that if there was somebody who can, understands this and starts explaining this, humans can pick that up and do it, right? So we are talking about very simple physics there in the football domain, right? It really doesn't matter whether the guy says, in fact, I have a much clearer path to the goal and I should just, slot the ball in.
Yeah. So
the existing knowledge is what is not available to which is not being able to absorb in the AI, right? So that is the challenge. More than
so this is the point that lots of people say AI doesn't have common sense. Instead of saying now the pathway to the goal is completely clear, because I don't see a defender, I should just kick it in, right? Instead, it says I expect to see a defender. I was trained with the defender standing up, right? So suddenly they lose. Yeah, I get it.
Yeah,
that's excellent. Actually, very, very good talk. Any more questions? Vincent, do you want to sort of, because both of you are talking on similar things, do you want to say something to Ravi's?
I think not at this point, because I think that would be unfair since I heard only a little bit of the talk. So
okay, that's maybe all right.
I can just say something about the bit that's in the chat there. The guns don't kill people. People kill people.
Please.
That's a pretty standard discussion in the philosophy of technology, right? So we know that yes, the moral agents that are responsible for actions are not the guns, but we also know that certain technologies enable certain kinds of things. So it is clearly the case that it's way more dangerous if you and me have a horrible argument and we both have a gun in our pockets. So if we have no tools in our pockets, we will both go away with a bloody nose, right? If we have knives, we might injure each other. If we have guns, then very likely somebody's going to get killed. So technologies have affordances, and these influence the outcome of human actions quite significantly. So that is why we do think that there is the point of having an ethics of technology.
George, are you there?
I'm there.
Yes, sorry, I didn't see that.
George is joining us from Canada. George works a lot on embodied self and self. Structure and learning, anything you want to add at this point?
No, not really. I think what is important that the self, but I think it was pointed out, is more sort of if at all, it's a computational structure, not just a specific content. Yeah. And whether of the sort of computational structure, of course, is a second question. Of course, I would argue it's a particular dynamic and topographic structure. Yeah. And the other thing which is important from my point of view, and that the self is not just inside the brain or the body, but it's sort of a virtual expansion, that the point of view, what philosophers call the point of view, is not just the first person perspective. It anchors you within the environment. Yeah, affordances. We were speaking about affordances. I think that's a key point here. Yeah.
I see it's very early in the morning in Canada.
Sherry, can I ask a quick question here?
Yes, please.
So this is follow up on this idea about structure. I don't know about the mathematics of many of these machine learning techniques. One thing that has always surprised me is that if I show a picture of, let's say, a horse to a very young kid, I show it twice or thrice, and after 3 times, the kid will figure out that it's a horse and this is a cow and this is a goat. Whereas if I have to train something like an ML kind of model, usually it requires thousands of iterations. So does it mean that there is a separate structure from which we infer about things to begin with, or the learning is somehow fundamentally very different? I mean, essentially the question is, why does it require only a couple of times for human brain to figure out that there is a pattern, rather than thousands of times or millions of times?
George is the neuroscientist here. I mean, yeah, the belief is that, yeah, we learned very differently to AI. That's the whole point, isn't it? That is the big debate between people who say we need a lot of structure. It is already keyed into our genome or whatever, all the structures are given, ready to, language, like Chomsky talks about. We are born with the whole structure of language. Whereas an AI would have to learn it from scratch, or however we think we need to train it, so it's our projection of how the AI could sort of pick up on it, give it large numbers of alphabets or words, and then, have it string together using statistics. So I think that is the debate of the century, isn't it?
So there's one other point, right? So as far as vision tasks go, recognizing the horse from a cow is not the first thing that the baby is solving, right? So even if the baby is not born with in an innate structure, right? I mean, it's been looking at constantly absorbing, visual stimuli throughout its life since it's born, right? So some of these, features that are needed for, representing the image has already been built by looking at other things. So this very, very natural, strong transfer that humans are very good at, right? That doesn't happen with tabula rasa AI system, right? Literally, you're learning from blank every time.
So it's more like a cumulative learning for us, and therefore we sort of tend to extract the patterns better.
Yeah.